All right, the next section that we'll talk about is triangles. So if you hear the word triangle just in general, what do you think of? Well, it's got to be a shape, right? So it's a shape with three angles. Again, tri meaning three, and then we're going to have angles. So when we look at this now, we introduce a few other words that you probably haven't really thought of, but in a sense you probably have used or you think you have used for a long time. And the first one is a segment or a line segment. So we're going to get into a lot of geometry in this section, but a segment is basically a line with endpoints. So from past, we know that a line has to be something that goes on into infinity in both directions. Well, now we're going to have a line, but we're going to cut it off at a particular point, and those are endpoints. So a line segment is basically what we've been doing, but now we're going to put dots, which is our endpoints at the end, and that's how we would name it. Whatever the endpoints are, that's how we would name that particular endpoint. So we're going to use the two letters at the end, and we're going to put a little bar over the top. The little bar just signifies that it is truly a segment and not a line. If it's a line, then we would include the little arrows at the end. So essentially, a triangle has all of these segments, or three segments that make up. So they make up the sides of your triangle. So obviously, every single triangle has to have three angles, but it also has to have three sides, and those sides are each going to be a segment. Where the sides come together, the sides meet at, so if we draw a triangle, now a lot of times they don't put these, but there's actually little dots here because there's endpoints at each one of them. What are each one of those endpoints, or where the sides meet? They are called the vertex, or at a vertex. So if I have a vertex, spelled it wrong. So if I have a vertex, that's each one of the points. And again, because we're talking about these points, a vertex is shown by a capital letter. And again, this is where we're getting really picky again. Remember how some of you wrote your y equals mx plus b with a capital B? Well, this is why you can't use that capital B in that situation, because in that situation we were talking about a lowercase b because we were talking about the y-intercept. Now we're talking about capital letters because every single time that you talk about an angle from here on out, no matter if we're talking about this class, geometry, pre-calc, whatever it happens to be, every time you see a capital letter, it tells you that you're signifying an angle in some kind of shape. Okay? So the vertex is where my sides meet, and they're all representing an angle, and so we use a capital letter. Going back to this, anybody have an idea what the word vertex is, as if we're talking about multiple vertex? That means we're having more than one, so the plural form of this is vertices. So that would be just something, again, maybe for ISAFs coming up or whatever you're talking about. So we always have a capital letter, and so if we're going to then talk about the sides, we would call each side by its segment, but we're going to name the triangle by the three letters, or three vertices of that shape. So my three letters are the vertices, or the actual angles in the triangle. And normally they try to write the letters in alphabetical order, but in all honesty, you can write them in any order. And then notice my little triangle symbol. So we always have to have a symbol. So I'm going to write that triangle symbol, and then I'm going to write my 3 vertices. Now again, it doesn't really matter, but I would try to write it in alphabetical order. Okay? So these are just kind of the basic things that we know about a triangle. And from there, then we start talking about the angles of a triangle. So this is really important. Does anybody know what the sum of all of my angles are in a triangle? Hopefully somebody knew that and responded that the sum of the 3 angles in a triangle is 180 degrees. And then don't forget about that degree symbol. Okay, so if I knew what this angle was and what this angle was, I could find out what my 3rd angle was by adding my other 2 angles together and subtracting from 180 degrees. All right, so we can find any angle that we want as long as we know 2 of the other angles that are involved. We can even do this with some algebra, and we'll show you that in just a second. From there then, because we know that they are added up to 180 degrees, they're going to give us examples of, they're going to say the ratio of the sides, and then they're going to give you what they would consider the ratio of the sides are. This means just the lengths of the sides. Okay? Or the ratio of the, sorry, I don't want to say sides because we don't know anything about sides right now in a triangle. We want to say the ratio of the angles of a triangle. So we could have done the sides, but that's more down the line when you know about like the perimeter or something like that. Now we're going to talk about the ratio of the angles. So we're saying what is the ratio to each other? And in this particular case, they're going to tell us that our ratios are 2, 3, and 5. And then they're going to ask you to figure out what is each individual angle in that particular triangle. All right, so remember now, you can basically draw whatever triangle you want. And then you'll have to just adjust it to make sure that your angles look like the degree measure that you actually came up with. So what I'm getting at is a lot of the times the triangles that you draw or maybe are given might not look like the angles are actually the same as the number that they give you. So they're not going to be drawn to scale. So if they give us these 3 numbers right here, they're showing us ratios. Remember, a ratio is just a fraction, but this is a different way of showing a ratio. You could use a semicolon, or you could use a colon, and you could use the word 2. But basically what we're going to do is you're going to pick a variable. So you're going to pick whatever variable you want. I don't care. I'm just going to keep it nice and simple, and I'm going to pick x. And so I'm going to give each of my numbers in my ratio that variable. So put the ratios with the variable. Again, if you don't use x, it's no big deal. You're going to get the exact same answer. You're just not going to do it the same way that we are. So we're going to give each one of my ratios the numbers that they gave us and put them with x. And then what did we know about the 3 angles in a triangle? We knew that the 3 angles would add up and equal 180 degrees. So if I know the ratios of the angles, I can add them up and still set them equal to 180 degrees. So basically now I'm just back to my algebra. Notice how my variables are all the same. So I'm adding like terms again. So what's 2 plus 3 plus 5? So basically we get 10x is equal to 180, and then I'm dividing by 10 from both sides. And so x is equal to 18. Now again, if they ask you just what x is, now I'm done. But if they ask you, they're going to ask you what are the angles if you know the ratios. So now I'm going to take this variable that I found, and I'm going to stick it back into every part of the problem to figure out what the degree measure is of every single one of my angles. So basically, I'm taking 2 times whatever we found for x, and then 3 times, and then 5 times. And every time that I do that math, then I will get an actual degree measure of my angles. So what's 18 times 2? We get 36. What's 18 times 3? We get, what, 54? And, oops, I replaced my x with my 18 again. And what's 18 times 5? What do we got, 90? 8 times 5 is 0, 4, yeah, 90. So realistically now, each one of these should get a degree symbol because they are the angles. And then the last thing that I can do is I can check my answer by simply adding those up, sticking them into my calculator if I have to, and see if they add up to 180 degrees. All right? So if you need another one of these problems, you can practice this by using the numbers 2, 4, and 9. So again, if those are the ratios that they give me, I'm going to give each one of those ratios a variable. So 2x plus 4x plus 9x. And I know that all 3 of my angles have to equal 180 degrees. 2 plus 4 is 6 plus 9 is 15. And x is equal to, I'm going to divide by 15 on both sides. So 1 looks like 12. And then I'm going to put that back in. So 12 times 2, 12 times 4, and 12 times 9. And then if I look at this, I'd have 140, 160, 172, 180 if I add them all up together. Okay, so this would be if they talk about the ratios. If you look on page 455 of your book, they're going to ask you to find that third angle in this. So on page 455, if you look 4 through 6, they're going to ask you to find that third angle. So they give you 2 of them, you add them up, and you subtract it from 180 degrees. All right? Any questions with this? From there, then, we try to classify triangles. And we can classify triangles in 2 different manners. We're going to be able to classify them by the angles, and we're going to classify them by the sides. So again, this will be a section where there's a little bit of new vocabulary maybe, but there's also going to be some old vocabulary. So we're going to try to classify triangles. And again, the first way is by the angles. Now, we've talked about angles before. What were the 3 words that we talked about with respect to angles? Well, we talked about the word acute, obtuse, and right. We use those 3 words to talk about an angle, and we're going to use those same 3 words to talk about a triangle. So keep this in mind, we'll come back to that in just a second, but the way that you got to think about it is that every triangle will always have 2 acute angles. So again, we already wrote that word up here, but what's that word acute mean? Remember that acute means that the angle is less than 90 degrees. So every single triangle is going to always have 2 angles that are less than 90 degrees. To name it then is going to depend on that third angle. And that's where these words come back into play. So every triangle has 2 acute, you name the triangle or classify it. Maybe we write classify instead of name because we're going to name it by those 3 vertices, but we're going to classify it by the third angle. So, we come back to our words. We already just said what acute meant. Acute meant that it was less than 90 degrees. What does obtuse mean? Obtuse means that it's greater than 90 degrees. And then what does it mean if it's right? It means that my angle is 90 degrees. And how do I show everybody in the world that that has to be 90 degrees? That's right, we use a box, right? Or it's kind of a half box, but it's usually shown with a red box in the corner. Now again, this is something very technical, but this is something that you need to get used to because it'll happen a lot. You cannot say that this right here, if I draw that angle right there, you cannot say that's 90 degrees until I put that box in the corner. If that box is not in the corner, I cannot make that assumption that it is 90 degrees. So keep that in the back of your mind. So again, we're going to classify the angle by that name and then use that name in order to classify our triangle. All right? So again, they're just going to give you some random numbers. Now again, not all of my triangles are going to be of proportion or look like they should, so take that into consideration. So if we have 63 here and we have, I don't know, 85 here, and then they put an X degrees down here. So they're asking you what is that angle and classify it by the angles. All right, so the first thing that we're going to do is we're going to take the 2 angles and add them together. So we need to know the total of the other 2 angles. And then we're going to take the other 2, or those 2 angles that we had, and we're always going to subtract it from 180 because we know the grand total has to be 180. So if I do my subtraction, 10 minus 8 is 2, 7 minus 4 is 32. So x equals 32. Now, if I had 32, 63, and 85, what kind of triangle do I have by this criteria? Again, I have 2 acute angles, so I look at that third angle, and this third angle is also less than 90 degrees, so my overall triangle would be acute. All right? So again, you can look at on page 455, number 4 through number 5, or 4 through 6 on page 455 would have you do that process also. So classifying by the angles, we can have acute, obtuse, or right. All right? That leads us to classify by the second way. So notice we had classify the triangles by the angles. The other way would be number 2, by the sides. So when we say we're going to classify the triangle by the sides, we're actually talking about if any of the sides are congruent. So this is another word that might be new to you, but congruent just means that they're the exact same measure. Okay? So it looks the same or has the same measure. All right? So that's going to tell you that they are congruent. So how do we know this? Well, there's a couple different ways that I can show if my sides are congruent. Number one way, by a number. So they can show me that the lengths of the sides are the exact same number. If the numbers are the same, then the sides have to be the same. So in my triangle here, compared to this triangle over here, they say that this is 14 and this is 14. Those 2 sides would be congruent because they have the same number. All right? Another way that you can do this and this is probably the more common way in geometry, is using slashes. So if we go back to the same example up here, and I say that this has one slash and this has one slash, that means those two sides that have just the one slash are congruent to each other. Now, if we want the other third side to be congruent to the third side, and they're different though than the first two sides that we said were congruent, we're still going to use slashes, but we're just going to use 2 slashes. And then realistically, you could also use 3 slashes on the last side, but we use numbers. So it's just a different way of doing that. All right? So from there then, we have to have 3 different ways, just like we did with the angles. So the angles were acute, obtuse, and right. Now we have if the sides are congruent or not. So these are words that you might have heard of. But if I have all 3 sides are different, meaning the lengths of every single side that was given to you is all different from all the numbers that they gave you. Anybody have any idea what this name is? Okay, so all 3 sides are different. This is called a scalene triangle. So again, this right here just means that you have 3 different sides. 3 different lengths of those sides. If I have 2 sides that are congruent, anybody have any idea what that word is? So hopefully, maybe you have heard of this, but this is an isosceles triangle. And again, a lot of times, like I said, they'll just show this triangle by putting the 2 slashes up there. And then, last but not least, we'd have all 3 sides are congruent. I don't know if we've said this before, but this is my congruent symbol. So it looks like an equal sign, but it then includes a little wavy sign on top of that equal sign. So all 3 sides, anybody have this? This one you might have heard of just because it makes the most sense maybe. And this is an equilateral triangle. So the other thing that you need to start thinking about, and I know this is probably way ahead of where we're at, but you got to think about that. The lengths of the sides in a triangle, okay? So if I have this triangle and then I have a really long triangle or a really long angle or a side, sorry. This side right here is opposite of that angle right up there. This side right here, or this angle right here is opposite of that side right there, and so on and so forth. But the lengths of the sides correspond with the, I guess, how big the angle is opposite of it. So because this side right here is the longest side, the angle opposite of that should be the biggest angle in the triangle, and so on and so forth. So realistically, if you take that into consideration of what we just said right here, if all 3 sides are congruent, we call it an equilateral triangle. If all 3 sides are congruent, that means all 3 angles should also be the same measurement, right? And if that's the case, what would each of those angles be? Well, in an equilateral triangle, all angles equal 60 degrees, okay? And then again, we go back to page 455, and they ask us to identify what kind of triangles we have. So again, you can identify or classify a triangle by the lengths of the sides or the lengths or the size of the angles. Okay? So by obtuse, acute, or right is because of the angles. By scalene, isosceles, and by equilateral are the sides. So you can classify each triangle by that. So in number 7, on page 455, If you look at this triangle, notice the little slashes on the side, and the angles opposite of those slashes are the same number. Okay, so what kind of triangle do I have in here? Notice the angles and then notice the sides. So how would we name it or classify it by the sides? Well, because they have two slashes, I'm going to call it isosceles. And then if I look at the angles, okay, I have 45 and 45. Those are my two acute angles. So I look at the third angle, and the third angle is 90 degrees. So we would call it a right isosceles triangle. Now again, here they don't use the box. If they use 90 degrees, you don't have to use a box ever. But if they don't say 90 degrees and they have a box, you automatically know that it's the same isosceles right triangle. So if I look to the one to the right, all of my angles are different. As soon as all of my angles are different, I know that all of my sides are going to be different lengths too. So if there's no slashes or all of my angles are different, my sides have to also be different, so I'm going to call it scalene. And then if I notice in my triangle, I have 110 degrees. Well, that's bigger than 90. So because it's greater than 90 degrees, one of my angles is, the whole thing is obtuse. And so it'd have a scalene, obtuse, or you can say obtuse, scalene, that doesn't matter, triangle. All right? And then last but not least, if I look at number 9, notice I have 75, 75, and 30. Again, if the angles are the same, the sides opposite of them should be the same. And notice in this case they are because they have the little slashes. So again, if I have two slashes, I know that I have an isosceles triangle. And then because all of my angles are less than 90 degrees, I have an acute triangle. So it would be an acute isosceles triangle. All right? So questions with any of this, please come and see me as soon as possible. I should be back by the end of the day. But here are the problems that you are going to do. Notice up here, if you can. So here are my numbers that we're going to do. It'll be up on the board also, but those are the numbers. Notice if you can see up there that it says there should be a quiz tomorrow, but we'll actually do another section on Wednesday in case you have some questions with this section. So we'll go on to section 9.5. And then the quiz will be on Thursday for you guys.